All right, so the question we are going to be jumping to is a math question. How can you find the volume of a cylinder?
Yeah, I guess I can take that one. Before we talk about volume of a cylinder, I kind of want to just talk about what volume is for a second. And I think volume of a cylinder in particular, if you think about like, this is kind of a cylinder shape. It's a little irregular, but it's got that like round top. The cylinder is going to be straight down. But if we think about what volume is, it's basically like how much stuff can you put in here. And if you think about like a really quick, easy kind of example that seems to make a little bit more sense to begin with. If we think about like the volume of a cube, and if I just sketch this really quick, see how this looks. Well, when you think about how it's related to area, area's got two dimensions where it's just like how much can you fit on this kind of flat surface, if that makes sense. Whereas when we talk about volume, we're trying to actually think about something more realistic, like how much can you fit inside of this space. So when we think about this, we have, like of a cube here, we have length, we might have width, and then we have height. So we're multiplying all of those together. And if you think about like how do you find the area of a rectangle, like down here, you know, if you think about a cube, well, a cube is made up of a square right here, and then we multiply it by the height because we need to kind of calculate and include that third dimension, right? When we talk about just like the area of a flat rectangle or a cube, you only have two dimensions, length and width. So in volume, we're adding that third dimension of height, which is why when you figure out like the volume of a cube, we do length times width times height. And if that's in inches, that's why we're always going to say inches cubed, because we have 3 dimensions. So I think a lot of students get thrown off when they think about like a cylinder or a shape that's not a cube, because it seems like a little bit more complicated. But I'm going to sketch a cube really quick using this tool. So it looks a little bit, or not a cube, sorry, a cylinder. So this is a quick cylinder right here. We can kind of again think, in particular a cylinder, we have a very specific equation for it. Because when you think about this, it's really like a circle that's been stacked on top of a bunch more circles, right? So every circle within here is the exact same size because it's just going straight up and down. So same idea that we were doing with the cube. Think about like how would I find the area of this circle that makes up the base, and how would I include that third dimension of the fact that this has actually some height here. So really quick, we'll just think about like what is the area of a circle, and that is area equals pi r squared. So that's just going to give me the area of that like bottom circle piece. But we have to consider this third dimension of the height here, right? Because again, we're kind of just stacking those circles all the way up. So when we have volume, we're going to say, we're going to look at the area, pi r squared, but then we're going to multiply it by that other dimension. Think like I have some number of circles stacked on top. So if I wanted to find the volume of a very specific cylinder, I would need to know the radius. So let's say the radius was 3. And I would also need to know the height. And so I'm just making up some numbers here, maybe a height of 4. All you're going to do is plug this into the equation. Volume equals pi. My radius is 3, so I'm going to do 3 squared times a height of 4. And then I'm going to simplify that, and I'm going to get 9 times 4, which is 36, or 36 pi. This would be your most specific if this were in inches. This would be inches cubed. But one thing I like to tell students to think about is like, let's say you were trying to find the volume of a can. If you told somebody like, oh, the volume of this can, this can hold 36 pi inches cubed of soda, that wouldn't really make a lot of sense. So this is one of those examples, like think about what you're being asked. And I would actually do this in my calculator, and I would simplify this into a decimal, 113.097 inches cubed, depending on how precise you want to be. So when you think about volume, think about like what you know about the area of kind of sometimes like the main shape, and this will change based on the figure you're looking at. And then think about like how you could incorporate that third dimension into it. So hopefully that helped.